Ladies and gentlemen, good afternoon. I'm Matthew Hardman, Chief Technology Officer for Hitachi Vantara here in the Asia Pacific region. Recently, I was asked to give a presentation to the Singapore Computer Society regarding hybrid cloud and some of the approaches that we're seeing customers adopting. Hitachi Vantara is a data-driven company, and we provide lots of infrastructure for data solutions for customers across things like block, file, object, and how do we enable the experiences that people are looking for at the application level. So those could be transactional databases all the way up to data lakehouses and AI systems. So it was an interesting topic to be able to talk about how customers are starting to look at hybrid cloud infrastructure to help them achieve some of the outcomes that they're looking for in terms of managing their existing application portfolio, as well as embracing some of the new ones going on as well. So I wanted to be able to showcase that presentation with you. So with that, let's get started. So I won't need to really introduce myself again. I've already done that. But the conversation that I wanted to carry with this presentation was really about choice. It's about the choices you can actually make to support your hybrid cloud infrastructure, which is therefore supporting your application. So as you go through, this is not about being told you have to choose one particular way of doing things. You have choice in architectures that will align to the organizational priorities you have, maybe the financial constraints you might have, or maybe unlocking some of the technology opportunities you see. So really, when it comes down to hybrid cloud, you do have choice. So for our agenda, there's 4 topics that I want to talk through. The first one is around data trends and what we see in terms of data today. The second one is around defining what is hybrid cloud or hybrid multi-cloud. So let me touch on the agenda for what we're covering today. The first topic I want to talk about is data trends. Now, of course, it's easy to say that data is growing exponentially, and it is, but that then results in a whole range of other trends that we're observing in the industry as well. And I want to touch on some of those aspects. The second topic is around defining what a hybrid cloud is. There are actually many different definitions in the industry for what a hybrid cloud is, and it becomes a topic that many people argue over. So I'd like to share how I see what a hybrid cloud is in terms of the customers we work with today. Third area is around large data sets and how this incorporates into a hybrid cloud solution, because we're starting to see these sorts of solutions that are consuming massive amounts of data. We want to be able to help organizations look at the different architectural choices they can use to be able to bring those solutions together to be productive and optimized from a cost point of view. And then finally, we want to touch a little bit on environmental sustainability. How do certain choices help manage sustainability efforts inside your organization? So let's start off with what is the state of data today? You know, when you hear people talk about data, quite often they're talking about data being the new oil, the new gold. It has a certain amount of precious value. It's really important, and data is about everything that we go ahead and actually do. And I can get behind that. I can respect that. But we see certain trends happening in terms of data today, right? Now, data itself is not a simple thing. It certainly is growing exponentially. We talked about this at the very beginning. We're seeing the growth of data become absolutely massive. The charts basically shows exponential growth as people are looking at the way that data is being generated. In the past, we might actually say, if I wanted a data point, like if I said, what's the weather like today? In the past, I might say it's 22 degrees and sunny. But now, the way we capture data, we're not just capturing the data point, but we're capturing how we capture the data point. If I were to ask that same question, what is the weather like today? I would answer it like this. Well, first, I'm going to look out my window and I'm going to assess and determine based on what I see if it's sunny or not sunny. I might go and look at my phone and try and look up the weather. Then I'm going to draw air into my mouth, into my lungs, and I'm going to store that air into my lungs, and then I'm going to push that air back out through my vocal cords, which will then help me to tell you the answer which I got from my phone is 22 degrees and sunny. that's kind of overdoing it. But the reality is that's kind of how we're capturing data today. We're capturing the data point, and the way we capture all the data, all the logs, all the information about that, we are paranoid that we're not going to capture enough. And so this exponential growth is driven a lot by the complexity of how we're capturing the data itself. So exponential growth is fairly significant. We're also seeing data now being generated everywhere, all over the place. Recently on a trip in China, I was looking around at all the different cameras that I saw everywhere, and that might be, concerning, but it also gave me a sense of safety. And I looked it up and I said, well, how many cameras are there in China? And I think the number was something along the lines of 600 cameras per square kilometer. I mean, that's an amazing number. Now, those cameras are capturing a lot of information, right? It might be, okay, we're capturing video images, but is those video images 1080p? Is it 4K? Like, is it 640 by 480? Obviously, the higher the resolution, the more information is being captured, and the more data is being captured. Then what's going with that information? Is it information about context and who was in the image, like how many people were actually there? So that is captured differently in different types of data. So we're starting to see a situation where huge amounts of data are being generated all over the place and being generated in certain different types: video, audio, logs, text, a whole range of different things. And then finally, there's a huge amount of untapped value. And we say untapped value, or I say untapped value, because I don't think all data is containing the same amount of value, right? There is some data which we capture which actually has no value, but we have that fear of missing out, that FOMO. We have to capture everything. We have to store everything. There is data which does provide huge amounts of value, but I wouldn't necessarily say that every single data point has the same amount of value. We see data being replicated and repeated. Does that incur value? Is that not valuable, right? So when I look at this, I typically would sort of say it's huge untapped value. So these are the things that we see data kind of pushing out. But as that data grows, as the variance of that data actually occurs, we also have pressures coming in from external. So we have huge amounts of regulation coming in on the data. And an IT professional no longer just needs to know IT, but they almost need to become a legal expert. They need to understand that the data they're working with potentially has some sort of regulation that needs to be applied to it. Data privacy, a whole range of different regulations that people need to understand. We've got challenges in terms of cyber resiliency. And this isn't necessarily just around ransomware, but just making sure things stay up all the time, right? You've got the DORA regulation, which has come through, the Digital Operations Resiliency Act, I think, if I get that right. And that's a huge pressure on people who are operating data systems. We also then have the need for innovation. And I think a lot of the marketing machines, which are being pushed from so many of the larger vendors, are really pushing organizations to say, you know what, you've got to be an innovator. Like, you have to do new applications. You have to adopt AI. And these things are great from a technology point of view. But every single wave of innovation puts incredible pressure back on organizations to be able to help unlock value in that, but also manage the risk as you start to adopt that. We don't want people to necessarily just throw data without caution to these new application services and not understand the repercussions of what that actually means. So, innovation's a big challenge for a lot of customers as well. And then finally, just skill sets. The skill sets to be able to manage this growth of data and how it's applied and how the regulations and the resiliency around it, all these different things that we've talked about, these are very, very challenging for a lot of people. So this situation we see, we call this the data effect. And this is what customers are facing today as it relates to all of the things that I spoke about. So this is a big challenge for a lot of organizations. Now, another thing which is really interesting we're seeing occurring is this concept of data gravity. Now, you may have heard the term data gravity before, but just in case, data gravity is this concept of when data is created or accumulated into a single space or a single location, you start to see a whole range of other things being drawn towards it. Sometimes that's new data sources are drawn towards it, that sometimes applications or services are drawn towards it, but data starts to have its own gravitational pull and starts to bring things together. So where we see the data being generated, we also start to see the applications being located, and those applications will potentially start to create data of their own, hence adding to the data gravity effect. Now, what's really been interesting about this is this isn't just a theory. In fact, it's something which is measured by an organization that provides this thing called the Data Gravity Index. It's by this company here called Digital Reality Trust Incorporated. And they've been studying this concept of data gravity. And if you look across the different regions, it's quite telling in terms of what data is being generated. And so what they're sort of saying here is that by 2025, APAC is going to generate somewhat around about 461,000 exabytes of data. You know, that's a lot of data, right? And if you think about where that data is going to be stored and how that data is going to be stored, it becomes quite a complex problem. Now, what it also calls out is that 90% of this data is generated outside of the public cloud, which means it's not being created in a public cloud, it's being created on premise. It's being created by all these different systems that are being outside of the organization. So if you think about the example with those cameras I talked about in China, there's a lot of data being generated there. That's not being generated in the cloud, it's being generated at the point, at the edge. The edge starts to become the biggest contributor to data generation in the world that we're facing today, right? So a lot of this data, 90% of the data is going to be generated maybe at the edge of the data center, not in the public cloud. And a lot of customers are concerned about the fact of where their data is and owning that data and a regulation. So this concept of data gravity is certainly something that many customers are starting to realize and starting to struggle with because of that growth of data. But again, they want the innovation. They want to be able to be first to market. But it is something that you need to realize and understand, where is data generation actually happening. So let's talk about what is a hybrid cloud, because we've talked about the data, right? The data is certainly a big challenge for people to be able to manage. But then what are the supporting architectures that help you take advantage of the data? And when it comes down to a definition on hybrid cloud, I've certainly had lots of heated discussions with people around what is a hybrid cloud. So I want to present to you my version of what a hybrid cloud actually is. So if we start off with the definitions, there's a concept of multi-cloud, right? Multi-cloud to me is siloed containers, and I don't mean containers in the concept of microservices, but encapsulated environments, I guess, of services that work in isolation of each other. So you might have applications running on your private cloud. You might have some applications running in a public cloud, Azure, AWS, Google Cloud, Ali Cloud, all those different clouds. But those applications don't necessarily interact with each other. They don't share data. They don't talk to each other. They are silos of operating services that is providing some measure of value for your organization. A hybrid multi-cloud is a solution where services, data, workloads are operating across those clouds together in unison, right? So if you think about it, a great example of a hybrid multi-cloud might be an application running its compute resources in the cloud, but it's consuming data from an on-premise storage. Now, certainly that architecture is not simple. It's not doable. You can go ahead and actually build those, but it's a little bit complicated today. But the idea is, how do you enable it that data can be used maybe on-prem where you're controlling it, you've got data sovereignty, and then how do you utilize the compute resources to be able to produce the results you're looking for. So it starts to think about workload portability or even data portability, but how do you have these cloud services interacting with each other? That is where we start to see a hybrid multi-cloud environment actually working. Now, in terms of some of the examples of where we see hybrid multi-cloud architectures happening today, there's a few of them. It's not necessarily one particular solution. Many different technology providers have been working on solutions for a while now to enable different types of hybrid cloud solutions. So one of the first ones which had been utilized a lot is how do you extend from, say, your private cloud to the public cloud? And one of the vendors which really enabled that early on was VMware. VMware, by Broadcom now we should say, enabled you to take a lot of your virtual machine workloads and extend those out to the cloud. And so you were able to extend your cloud from the private cloud into the public cloud and actually have a unified environment. That sort of gave you manageability from a single location and have those applications working with each other. So extending from private out to public and providing a service that way. The second one is really about how you extend from public to private. Now, obviously, there's lots of customers who kind of like the services and the solutions that they're getting from vendors like Google and Azure. And what they want to be able to do is bring some of those services on premise. Like there may be situations where they have applications that they can't run in the cloud. So they want to bring those cloud services into an on-premises environment. So Azure Arc, for example, is a great way to bring some of those Azure services on-premise. Google Anthos is a great way to bring that together as well. They've got some cool technologies they're working with where you can provide or provision containers and microservices. So you can choose them from the Anthos catalog and have them running connected to your infrastructure on-premise. Each different vendor has their own technology to be able to make this actually work in different application architectures. But what's kind of interesting is that the AWS and VMware one, the Azure Arc and Google Anthos, they're sort of bridging into hybrid cloud. It feels more like hybrid management. They sort of manage the on-prem and the local execution. It's not really sort of data from one location and applications on the other side. But it's getting there, right? That's where we're seeing those two environments come together, the cloud and the on-premise one. And then the other one, and this is where we're starting to see true hybrid cloud coming in, is where we bring data closer to the cloud. And this is using co-location. So some co-location providers actually not only provide co-location services for enterprise, but they also host a lot of the public cloud companies as well. And they are able to provide direct connections from their co-location into those cloud service providers. So what you see in this situation is you can deploy your data in a co-location environment that you own yourself and then have the direct connections into those clouds. Now, we've actually done this before. We've actually tested this and showcased how this works for customers, because we had one customer, I think it was in Hong Kong, was saying, hey, can I actually have my data in a colo and then have that consumed by EC2 instances in Amazon? I want to be able to control that in my own environment. Now, a co-location by legal definition is owned by the customer, and they're able to have their data in the colo on their premise, and then they're using the direct connect to Amazon to consume the data and actually work on it. And the initial thing was, when we looked at this, we sort of said, well, the performance of this can't be very good. You're still sort of going outside the cloud. But as it turns out, the performance of this architecture was actually really good. It met the same performance of what you could do fully in the cloud as well, because we weren't necessarily doing public connections between it. It was a direct connection to the service. So we were able to demonstrate it met the performance requirements, did what you could do in the cloud, and in some cases it performed even faster. So these solutions, this sort of near cloud environment, can give you that speed of processing or speed of compute with your data separate from the cloud, but you're maintaining the cloud under your conditions. So this is another great way to be able to go and provide a hybrid cloud option as well. Right, so let's now talk about strategies for how you actually manage data inside the cloud itself, because there are going to be instances where you have compute and applications up in the cloud that you need to bring data as close as possible to be able to help you perform that speed of processing. We've all heard catch cries and phrases about how important data actually is. This gentleman here, Clive Humby, he came up with the phrase, data is the new oil. We've heard other things like data is gold and those sorts of phrases. What's interesting to me is that when we say data is gold, it infers it's an object that can potentially be morphed and crafted into a thing, but it doesn't necessarily go away. It's just changed. Oil, though, oil is something that we consume to help us achieve an outcome. And I think that's interesting. Take, for example, a car. If I want to move my car from point A to point B, my objective is to get somewhere. But the oil I use to power the car, sure, it's costly, it's important. I put it in the car and it helps me get there. But by getting to the objective point, by getting to the end goal, I've consumed the oil. And maybe that's a way that we need to think about data as well. We have this tendency to have to hold on to everything, but perhaps there's more intelligent ways we can utilize data as oil to help us achieve the outcome we desire. Now, of course, data being very, very important to us, we also need to ensure that we can store it and protect it in the right possible ways. And what I've tried to do here is to compare the industry costs of storage, solid state storage per gigabyte, against what you would pay for general purpose storage in the cloud. The red line shows us the industry cost of storage. So back in 2014, it was somewhere between 35 and 40 cents per gigabyte, and that dramatically came down to the point where it started to flatten off in the early 2020s to around about 5 cents per gigabyte per month. Now, compare this to the cost of storage in something like Amazon, which has always been around about 10 cents per gigabyte per month. And I stress on the per month because when we look at the cost of storage in the industry, you buy it and then you own it. But this cost of general purpose storage is per gigabyte per month. So within 1 year, it's not just 10 cents, it's 12 months by 10 cents. So $1.20 per year for 1 gigabyte of storage. Now, what's interesting to me is that while the cost of storage in the industry has come down, the cost of storage in the cloud hasn't changed. Now, yes, you could argue that there are costs associated with operating the service and maintaining it and all those different things, but the fact that the cost of storage in the industry is coming down so dramatically, surely we would see some sort of shift in general purpose storage in the cloud, but it hasn't happened. So when we think about storing data in the cloud, we need to think about ways we can be clever in terms of how do I mitigate the risk of cost spiraling out of control as I start to add data into the cloud to get a potential outcome. So what about using data like oil? How do we think about data being something that we use to drive an outcome and then consume the actual resource? Now, I'm not necessarily saying that once you've used the data, then just destroy it and never use it again. What I am saying, though, is if you move data around, there's probably not much value or benefit in having multiple copies of data all over the place as well. So there's a couple of ways you could think about utilizing your data with these sorts of cloud services. One of those ways is to replicate data, get your outcome and delete it. So if you imagine we've got the data being captured on premise, and we talked about it before that 90% of data is being generated outside the cloud. So why don't I replicate the data set to the cloud? I ingest it into the services that I'm utilizing. I produce the output and then delete the data from the cloud. So I move it to the cloud for the purpose I need it for, get my objective done, then delete the cloud. Sure, I continue to maintain it on premise. I have a copy of it there. I'm protecting it with my enterprise or commercial services and software, but I'm not necessarily having to maintain two different copies. I replicate it up to when I need it. And this ingest doesn't cost anything, right? We ingest it up into the cloud, we utilize it, and then we delete it. Another way we could actually do is to utilize in place. Now, this is utilizing the same concept as the co-location we talked about earlier. So I have my data store in a co-location premises. They operate and manage it. It's under legal terminology, it's still my premises. And here what I'll do is I'll read the data directly from the co-location through a direct connect. I will get the outcome, but the data never leaves my colo. It's being consumed directly into the cloud. I'm getting the speed and performance. I'm under control of the data. This is a great way to be able to use the data and not have multiple copies everywhere as well. And then the last one, which is similar to replication, would be to cache information to the cloud. And this is really just drawing the information in as you need it rather than doing a full-blown replication. So I cache some aspect of the data. I utilize it in my services and process. Once it's done, I delete the cache, and then I have the outcome there again. So both the replicate and delete and the cache to cloud utilize data like oil. We move the data to where we need it to be processed. We process it, and then once we've got our outcome, we go and delete it. Obviously, it's a bit more of a controversial way of looking at it because some people say, well, I'm moving data around all the time and all those different things. But I guess you've got to compare. If I just have data sitting there and it's not being utilized, but it's consuming costs for my organization, is that a better outcome than being a little bit more orchestrated with the data itself? Now, the last thing I want to talk about is the whole concept of, hey, if I move everything to the cloud, surely I'm going to be able to achieve my goals on environmental sustainability because I want to move all of my infrastructure and my data off a data center, and I want to look at retiring that. So that means it's not my responsibility for environmental sustainability anymore. That's an interesting thought, but let me show you something here and talk about the scope of emissions. So let's talk about sustainability. And it's important to recognize that sustainability is not just one simple thing. It's actually a number of different areas that we need to consider. So there is environmental sustainability, there is social sustainability, and there is economic sustainability. So these are the three areas of sustainability that many organizations need to consider. For this slide or this concept, we're going to talk about environmental sustainability and greenhouse gases and how that impacts the environment itself. When you talk about environmental sustainability and your impact on the environment, it's important to understand that there's this idea of scope of emissions. And in the scope of emissions, there are three types of scope. Scope 1, Scope 2, Scope 3. Scope 1 or direct emissions is what you control yourself. These are the lights that you have in your office, the temperature that's been set in the aircon, how much aircon you're using, things that you can actively control yourself. Those all create some aspect of environmental impact or greenhouse gases. You control what you do. Scope 2 emissions are indirect emissions. These are ones that come from the organizations who would produce your electricity. So when you are consuming electricity in your business, you are getting electricity from a certain provider. Now, the way they provide that electricity or generate that electricity is part of your indirect emissions. So if you choose to work with an electricity provider who generates electricity by burning coal, then your emissions would be much higher versus a provider who generates electricity from solar or wind or more sustainable options, I guess. Now, obviously, you need to compound that with how much electricity you are consuming. So if your business consumes lots and lots of electricity and you do it with a coal provider, a provider of electricity that generates through burning coal, then obviously your indirect emissions are going to be very, very high. So people look at this and say, well, how do we reduce our electricity consumption to reduce the actual impact? And then scope 3 is other indirect emissions. And this is the emissions of the organizations that you work with in the process of doing what you do, right? So it's with partners who maybe provide you products. So when you're shipping your products to another customer and there's a logistics company and they have lots of cars on the road, you kind of own that aspect of the emissions from the cars as they're delivering your product. You can't necessarily control the company's emissions, but you do take responsibility for that. So scope 1, scope 2, scope 3. Now, people look at this, especially with the concept of scope 1 and scope 2, and they say, well, if I move all of my workloads from on-premise to the cloud, I can sort of scale down my data center and I'm not consuming so much electricity anymore, right? That sounds like a great thing. And it does. But what you are doing is you're not absolving yourself of the responsibility. You're moving your emissions from scope 1 and scope 2 into scope 3. So you still own that, right? And so you need to recognize that just moving things to the cloud doesn't necessarily say, hey, I did a great job on environmental sustainability. You've simply moved the emissions or the registration of those emissions from scope 1 and scope 2 into scope 3. Now, I don't want to say bad things about cloud providers. They are certainly doing some incredible things to help with the environmental impact. I mean, some of the areas that people talk about, such as the production of concrete for data centers, there's huge scope for improving the environmental impact of that. And a lot of the big hyperscalers are doing a lot of work there. But I think it's a very simplistic way to say, if I move things to the cloud, I'm going to be better for the environment. Maybe we need to think about optimizing the ways we build applications and use data is going to help us have a better impact on the environment. So, ladies and gentlemen, that's it for the session that I presented. Like I sort of said, hybrid cloud architectures are going to be prime for what we're looking at doing in the future around, the excitement around AI, data lakehouses, and then the next application beyond that. To be able to embrace a lot of these next generation applications, you've got to be able to get your data portfolio platform in good working order, and gives you the flexibility to be able to take advantage of these new waves of innovation. We're already hearing today that many customers are already running out of data to be able to train their AI models, and they're starting to rely on synthetic data. They're going to have to store that data somewhere because the data they capture gives them the competitive advantage. So I hope you'll look at your data portfolio. I hope you consider hybrid application architectures for where you're headed. And I hope you'll actually consider Hitachi Vantara to help you get there as well. Thank you so much for your time today, and have a great one.